April 2026. The MV Hantavirus, carrying roughly 150 passengers and crew, navigates the remote, icy waters of the South Atlantic. It was supposed to be a standard expedition to the southern edge of the world. Then, a 70-year-old Dutch passenger developed a sudden fever and internal bleeding. Days later, he was dead. By the time his body was offloaded, his wife had fallen ill and died. Shortly after, a German passenger passed away, and a British tourist had to be airlifted out in critical condition. Ports immediately began refusing entry. When medical teams finally boarded the vessel, they arrived sealed inside full protective gear, walking the tight corridors of a completely locked-down ship. The passengers were trapped thousands of miles from home, completely surrounded by ocean, while an unidentified, highly lethal pathogen moved quietly from cabin to cabin. For anyone watching the news, the optics triggered an immediate, visceral reaction. We all remember the Diamond Princess in early 2020 and the domino effect of cruise ship quarantines that signaled the start of a global shutdown. The fear was instantaneous. People saw the headlines and assumed they were watching the birth of a new, highly contagious airborne pandemic that would drag the world back into severe lockdowns. But when the lab results finally came back, they completely contradicted that panic. The passengers were not dying from a novel coronavirus. They were infected with the Andes strain of Hantavirus. Global health experts immediately urged calm. To understand why a virus with a mortality rate this high isn't triggering a worldwide lockdown, we have to trace its quiet 70-year history. The story starts in 1951. United Nations troops fighting across the Korean Peninsula suddenly began collapsing from an unknown illness. They suffered from severe headaches, internal bleeding, and sudden kidney failure. Military doctors had nothing in their medical text to explain it. The illness tore through the ranks, infecting over 3,000 soldiers and killing roughly 1 in 5 of those who showed early symptoms. The war ended, but the pathogen remained unidentified for another 25 years. It wasn't until 1976 that South Korean scientist Ho Wong Lee finally found the culprit, hiding inside small field rodents captured near the combat zones. This map highlights what researchers believed after naming the virus Hantaan in 1980. They drew a strict old-world containment zone across Asia and Europe, mapping a vector where the virus only transferred to humans who inhaled dust from infected rodent droppings. Because researchers defined Hantaan as a geographic anomaly specific to Asia and Europe, the search for similar pathogens in other regions slowed. For decades, this old-world classification kept scientists from looking in the Western Hemisphere. That geographic assumption held until May 1993. In the American Southwest, a healthy young Navajo man woke up unable to breathe and died within days. His fiancée had suffered the exact same rapid respiratory failure 5 days earlier. The CDC rushed to the Four Corners region as more cases surfaced. Urgent lab work identified the culprit, a native, previously unknown New World strain of hantavirus. They called it sin nombre, the virus without a name. Instead of attacking the kidneys, it aggressively attacked the lungs, causing rapid fluid buildup. Its mortality rate was a devastating 40 to 50%. This lethal strain relied on an everyday host, the North American deer mouse, a species found in nearly every corner of the United States. When investigators tested frozen tissue samples from older, unexplained respiratory deaths, they found sin nombre present in cases as early as 1959. The virus had existed in the United States unrecognized for over 30 years. The Southwest outbreak proved that Hantavirus wasn't confined to a single hemisphere. It was a global presence, living quietly in local rodent populations, waiting for human contact. Up to this point, every identified strain of Hantavirus shared one strict biological rule. A person could catch it from a rodent, but they could not pass it to another person. The human body was a dead end. This diagram shows the exception. Left, the standard dead end. Right, the Andes strain, localized to Argentina and Chile. It's the only outlier documented to spread human to human. That single mutation changes the math. It's why this strain, on a confined cruise ship, sparked an international emergency. Which brings us back to 2026 and the quarantined MV Hantavirus sitting off the coast. Epidemiologists quickly retraced the steps of the initial victims. Before boarding the ship, the Dutch passenger had traveled through Argentina, eventually visiting a local landfill site where he likely came into contact with infected rodent droppings. Because doctors immediately sequenced the virus and identified it as the Andes strain, they knew exactly how it behaved. The intense global panic surrounding the ship simply didn't match the actual epidemiological threat. In early 2020, science was racing to understand a completely novel virus. Here, health officials have decades of hard data on exactly how this pathogen transmits, incubates, and kills. COVID-19 thrives on casual, airborne contact. You can catch it just by breathing the air in a room someone walked through. Hantavirus operates on the exact opposite mechanics. Even the human-to-human Andes strain is a sluggish traveler. It requires prolonged, close physical contact or the direct exchange of bodily fluids. Sharing a dining hall isn't enough. You essentially have to be caring for a sick relative or sharing a bed. Public health officials immediately hit the press to separate the biological reality of the Andes strain from the lingering, generalized anxiety of the COVID era. Instead of guessing who is sick based on symptoms, the current containment strategy relies on high-volume molecular PCR testing. Authorities can run tests on every single passenger and crew member to definitively separate the infected from the healthy. Because the virus has a massive incubation period of up to 6 weeks, more cases will emerge from the ship. But because those passengers are already in strict quarantine, like the 17 Americans currently being monitored in Nebraska, secondary transmission stops before it starts. Our collective trauma from the pandemic makes every new outbreak look like the end of the world. But containing a deadly pathogen doesn't require zero infections.